7.3, the law of cosines. So we just did law of sines, now we're doing law of cosines. Alright, so triangle side length restrictions. If any triangle, the sum of the lengths of two sides must be greater than the length of the remaining side. So, might remember that, might not, from geometry way back in the day, but if you add up two sides, any two sides, they have to be larger when you add them up than the remaining side. Law of cosines. In any triangle ABC with sides ABC, we have three laws of cosines. So if we're trying to find side A, we can use this law. If we're trying to find side B, we can use this law. If we're trying to find side C, we can use this law. We could also use the laws to find our angle, because that's right, that's what cosine A, cosine B, cosine C mean. They mean angles. If C is 90 degrees in the third form of the law of cosines, then cosine C equals 0, and the formula becomes C squared equals A squared plus B squared, and that's the Pythagorean theorem. So, we're talking about that one right there. Alright, a surveyor wishes to find the distance between two inaccessible points, A and B, on opposite sides of a lake. While standing at point C, she finds that B equals 259 meters, A equals 423 meters, and angle ACB measures 132 degrees, 40 minutes. Find the distance C. Alright, so we're trying to find this distance right here, across the lake. Alright, let's see what we're given. So we're given... We're given B, which is 259 meters. We're also given A, which is 423 meters. And we're given an angle ACB. So we're actually given angle C. It's always in the middle. So angle C, which is 132 degrees, 40 minutes. So we're given two sides and an angle. And you see how they're all different letters? We have A, B, and C. It doesn't matter if they're sides or anything. Every letter is different. When every letter is different, you use the law of cosines. So since we're trying to find side C, we need to use this law right here, because that's what we're trying to find is side C. So we're going to be using the formula C squared equals A squared plus B squared minus 2AB cosine C. Your side that it equals and your cosine should be the same variable, and then the other letters that we don't have, that's what's going to go in the middle. Since we're trying to find side C, the remaining letters are A and B. Alright, we have our A, B, and we have our value of angle C. So our B, which was the 259, and A, which is 243. And then we have our value of cosine C, so our angle, which is 132 degrees, 40 minutes. So let's find C. We have C squared equals A squared, so 243 squared, or 423. I said it too. There we go. 423 squared plus B squared, which is 259. And then that's all minus 2 times A, which is 423. Or excuse me, yep, that's right. I keep wanting to say it backwards. Times B, which is 249. And that's all times cosine C. There we go. Jeez, oh my gosh. Okay. So you know that whatever we do, we need to figure this out. Come on, right. I swear my tablet has been just messing up today. Alright, so we know when we solve this, we're going to eventually have to take the square root, right? So when we plug it into our calculator, we're going to plug all of this with the square root. Okay, I'm actually going to show you how to do that right now. Alright, so we have second x squared, that's going to give us our square root, and then we're going to plug everything that we have. So we have 423 squared plus 259 squared. Oop, my bad. Technically, it won't change it, but I want it to be exact. That's what we have. And then minus 2 times a, which is 423, times b, which is 259, and then cosine c, which is 132 degrees, so second apps, enter, 40 minutes, so 40, second apps, number 2, close out those parentheses, and then to get our value of 6298.1007636. So we get side C is approximately 628 meters. 3 significant digits, that's why we rounded it to 628. If you don't like to do it step by step, this part right here, if you didn't square root it, it would be 3,900, or 30, blah, 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 300,094, 510.6. And then we would take the square root of that, okay? All right, next example. We are going to solve triangle ABC when A is 42.3 degrees, B is 12.9 meters, and C is 15.4 meters. So how do we know to use law of cosines or law of sines? No variables match. We have A, B, and C. It doesn't matter if they're angles or sides or whatever. No, none of the letters match. Since that's the case, we use law of cosines. So since we're trying to solve that triangle, we need to know that we need to find angle A, angle B, angle C, side A, side B, and side C. So that's what we need to find and have to solve this triangle. All right, let's figure out what we already have right now. So we are given angle A, which is 42.3 degrees. We're given side B, which is 12.9 meters. And then we're given side C, which is 15.4 meters. All right, now all we need to find is the remaining side and 2 angles. So since all the letters are different, we're going to use our law of cosines. So what do we find first? You find the one with the matching angle. So you see how we're given angle A? That means we're going to be using A squared equals B squared plus C squared minus 2BC cosine A. The reason why we use that is because we're given angle A. Whatever angle you're given, find that side first. Let's plug everything that we have in. So we're trying to find A. We have A squared equals B squared, so 12.9 squared, plus C squared, so 15.4 squared, minus 2 times B, which is 12.9, times C, which is 15.4, times cosine A, so cosine 42.3. All right, when you plug all of that into your calculator, approximately you'll get a squared is approximately 109.7. Take the square root, and we get A is approximately 10.5 meters. We round to 3 significant digits because that's how many digits we started off with, was 3. So we have side A, which is 10.5 meters. Awesome. Now that we found the side to the angle we're given, we can use anything else to find whatever. We can use law of sines or law of cosines. Honestly, you always start off with doing law of cosines and then you switch to law of sines. So now that we had everything different, we use law of cosines. Now that we have some things that are matching, we're going to be using law of sines. So go in order of what you're given. So you see how we're given angle B, then angle A, then side B. So that means we're actually going to find angle B next, because that's what's next in the order. All right, so let's go ahead and find angle B. I'm going to do it right here, because it's going to take some space. I'll go to the side. All right, let's find angle B. So to find angle B, we're going to be using law of sines. So we have sine B over B equals, always use what you're given. Since we're given A, let's use sine A over A. So we have sine B over our B, which was 12.9. And that equals sine A, which is 42.3 degrees. And that's over A, which we just found, of 10.5. Alright, by now, you know you cross multiply. So we cross multiply. And when we do, we get 10.5 sine B equals 12.9 sine 42.3. We divide by 10.5. And when we do, we get sine B is about 0.826, 8439452. So to get angle B, we take the inverse of sine. Right, we plug all of our decimal in, and we get angle B is approximately 55.8 degrees. All right, cool, we found angle B. Now we find the last angle. Anytime you have two angles and you need to find the last angle, you just subtract from 180. So let's go ahead and do that. So angle C would be 180 minus 55.8 minus 42.3. And we get angle C equals 81.9 degrees. Alright, we solved our triangle because everything in that box is filled out. We found all the angles and we found all the sides. And that's all we need. Alright, let's keep going. Had we used the law of sines to find C rather than B in example 2, we would not have known whether C was equal to 81.7 degrees or its supplement. So that is why we go in order to which they give us, because it's going to set us up at the end. So we know we won't have any mistakes. So meaning, see how we're given angle A, then side B? That's why after we found side A, we went and found angle B, because that is what was next in the order in which they gave us, was side B. So that's why we found angle B. And then last was C. That's why last we found C. Okay. All right. Side, side, side. So we're given three sides now. We have side A is 9.47 feet, side B is 15.9 feet, and side C is 21.1 feet. So we have not been able to solve side, side, side. Now we're going to learn how to find side, side, side. We use the law of cosines. So since we're solving this triangle, we need to find all our angles and all our sides. But since we have side, 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 we know that all we need to find are our angles. And there's only one way to start this. Only one. All right, our first step is to identify the largest side. So our largest side is C, which is 21.1 feet. That's our biggest side. Awesome. So you know what that means? We need to find that angle first because it's the largest side. So finding the largest side is going to help you finding the largest angle first. So that's why we're going to find angle C first. So C, angle C comes from the C squared one. So because we need to find angle C first, that is originally in C squared equals A squared plus B squared minus 2AB cosine C. That's where we get C from, or that's where we can plug it in. So now we need to isolate my bad. That was our second step. Our second step was to figure out what formula to use. All right, our third step, we need to isolate cosine C. Because isn't that what we're trying to find? We're trying to find C, so that's why we need to isolate it. I need way more space than this. Oh my gosh. Of course, now I want my keyboard and it doesn't come up. There we go. Yep, I need a ridiculous amount of space. Alright, so in our law, let's go ahead and isolate it. So we have C squared equals A squared plus B squared minus 2AB cosine C. So the first thing that we're going to do is subtract A squared. And then we're also going to subtract B squared. So on the left side, we have C squared minus A squared minus B squared equals negative 2AB cosine C. Last thing we're going to do is divide by negative 2AB. So to find cosine, we're going to use C squared minus A squared minus B squared over negative 2AB equals cosine C. All right, now that we isolated it, our fourth step, we're going to plug in all the sides to find the angle. So again, our sides that we have C, which is 21.1. We have B, which is 15.9. And then we have A, which is 9.47. So let's go ahead and plug it in. Now we'll that and bring it out. So all that means is we're going to multiply by a -1 to everything. So we'll have negative c squared plus a squared plus b squared over positive 2ab equals cosine c. So yeah, I mean, we could do that, down here. We could change it down there, but I like to change it as we plug it in. I don't know, just something I do. It doesn't matter when you change it, but definitely take out that negative, okay? If you don't, you're going to get different answers. You will. So let's go ahead and plug in the values that we have. We have negative 21.1 squared. Then we have plus a squared, so 9.47 squared. And then we have b squared, so 15.9 squared. Sorry, there's a plus in between. And that's over 2 times ab, so 9.47. And then we have our b, which is 15.9. And that all equals cosine c, because that's what we're trying to find. All right. Let's plug this into our calculator. I'll walk you through it. So with our calculator, we have our values of, so fraction first, negative 21.1 squared plus 9.47 squared. And that's all plus 15.9 squared. And that's all over 2 times 9.47 times 15.9. And we get a decimal. So after we get that decimal, you hit second cosine, scroll up to your decimal and press enter. Press enter again, and we get our value of our angle. All right, I'll write all that down. So when we plug this into our calculator, we get cosine c is approximately negative 0.34109,402, what was it, 808. And that was what cosine c was. So then we take the inverse of cosine. All right, plug our decimal in. So we get c is approximately 109.9 degrees. Alright, so since we use the law of cosines to find our first angle, we now go to law of sines to find the second angle. What angle do I find next? So you don't go in order in which they gave it to you here. You go from largest to smallest. So now we're going to work on our medium angle. Our medium angle would be B, because medium side is B. It's also known as intermediate side, but I like to say medium because that makes way more sense to us. So the medium side is B, so that means we need to find angle B. So to find angle B, we use law of sines. So sine B over B equals, use what you have. We only have angle C, so that's what we have to use. So we'll use sine C over C. All right, let's go ahead and plug what we have in. We have to find B, so we're doing that. Sine B equals side B, which is 15.9. And that equals sine C. So sine our C value that we just found of 109.9 degrees. And that's over C, which is 21.1. We cross multiply. All right, by now, you should definitely know how to do this. I'm just going to give you the angle. So angle B is approximately 45.1 degrees. Now we just subtract those both from 180, so we have 180 minus 45.1 minus 109.9. And that's going to give us angle A. So angle A equals 25. It's 25 degrees, but we have to use significant digits, so 25.0 degrees. All right. Find angle B to the nearest degree for the truss shown in the figure. A truss is how they build, it's used to build roofs and staging and stuff like that. So, angle B, that's what we're trying to find. So since we're trying to find angle B, we know that that's going to come from B squared equals A squared plus C squared minus 2AC cosine B. All right, let's identify what A, B, and C are. So across from angle B, that's where you get your side, which is 6 feet. Across from angle A is 11 feet, so A is 11 feet. And then across from C, we get 9 feet. So C is 9 feet. Let's plug everything in. Oh, sorry. Before we plug everything in, you can solve for cosine now, or you can plug everything in and then solve. So it doesn't matter how you do it. I am going to solve for cosine first, okay? So solve for cosine first. I am going to subtract A squared and C squared. So we'll have B squared minus A squared minus C squared equals negative 2AC cosine B. Divide by negative 2AC. So we get B squared minus A squared minus C squared over negative 2AC equals cosine B. Now I'm going to take that negative out. So when I take that negative out, we'll have negative B squared plus A squared plus C squared over 2AC equals cosine B. Now I'm going to plug everything in. So I'm going to plug everything in. I have negative B squared, so 6 squared, plus A squared, so 11 squared, plus C squared, so 9 squared, and that's all over 2 times A, which is 11, times C, which is 9, and that is what cosine B is. All right, so we plug that into our calculator. We get cosine B is approximately 0.83838384. We take the inverse of cosine. All right, we plug that in. So angle B is approximately 33 degrees. All right. These are 4 possible cases when solving an oblique triangle. So if you have one side and 2 angles, you find the remaining angle and then find the remaining sides, so you use law of sines. If you have 2 sides and 1 angle, not included between the 2 sides are known, so this is an ambiguous case. There may be no triangle, 1 or 2 triangles. So we find an angle using the law of sines, find the remaining using the angle sum formula, which is A plus B plus C equals 180, and then find the remaining side using the law of sines. Case 3 is when you have side angle side. So 2 sides are the included angles and the included angles are known. Find the third side using law of cosines. Find the smaller of the two remaining angles, then find the remaining angle. And then if you have side, 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 you find the largest side, and then work your way down using law of cosines. All right. Heron's area formula given side, side, side. So you can find area of a triangle if you only have the sides. So the first thing we need to do is find our S, and then we can use our formula. So the distance as the crow flies from Los Angeles to New York is 2,451 miles. From New York to Montreal is 331 miles, and from Montreal to Los Angeles is 2,427 miles. What is the area of the triangular region having these three cities as vertices? Ignore the curvature of the Earth. All right, I'm going to do my best to draw the United States so we can kind of figure out what we're talking about here. All right, so it's pretty flat up here, and it goes up, right? That's like New England, and then it kind of goes down, and here's Florida, there's Texas, and then California is like that. Okay, that's my best drawing of the United States. All right, so it's saying we have Los Angeles to New York. So LA is like somewhere around here. I accidentally drew part of Mexico, but that's okay. And then to New York. So New York, somewhere up here. And it's telling me that from LA to New York, it's 2,451 miles. So from here to here, it's 2,451 miles. Then it's saying New York to Montreal. So Montreal is in Canada, is like just above New York. It's about right there. So New York to Montreal is 331 miles. That means this distance here is 331 miles. From Montreal to LA, it's 2,427 miles. So what we're trying to find is the area. This right here. That's what we're trying to find. So let's identify and label our sides. It doesn't matter what you label it, just label A, B, and C. So we're going to say A is 2,227. We're going to say B is 2,451. Oh, my bad. Wrong color. And C is 331. Those are all interchangeable. Just label them right before you do anything. Now that we labeled A, B, and C, we can go ahead and find S. So S equals 1/2 A plus B plus C. So we have 1/2 A plus B plus C. When we add those up and divide by 2, we get S is approximately 2,604.5. Now that we have S, we can go ahead and use our area formula. So we have area equals the square root of S, so 2,604.5 times S minus A times S minus B times S minus C. Plug that into your calculator exactly the way it looks, and you get area is approximately 401,700 miles squared. And the reason why we went to 4 significant digits is because we started off with 4 significant digits right here. See, 4 significant digits.